question 6, part A. We shows a stereoisomerism. Under stereoisomerism, there are two types. So it's the optical isomerism and the cis-trans isomerism. Part 1. Explain what it means by stereoisomerism. So for this part, you need to mention what is the same and what is the different. Okay, so the molecules with the same structural formula and molecular formula. Okay, this is the one that shared by all the isomers, means all the stereoisomer. For the cis-trans isomer or optical isomer, they will share this structure. Again, they will share the same structural formula and molecular formula. Of course, you should know what is the structural formula and molecular formula. Right. So structural formula is the one that let us know how it looks like, how the atom arrange in the molecule. And molecular formula is the numbers of the atoms for the certain elements. Right. So means the cis-trans isomer and optical isomer, they must have the same structural and molecular formula. They're only different in this part. Different in the arrangement of atom in space. So this one is how they arrange. Means cis-trans, we know that. Okay, as long the CC double bond has the different group. Let's say we use this example in figure 6.1. So this CC double bond, we know that this carbon has two groups, one hydrogen and one hydrocarbon here, or one large group here. And this carbon has one hydrogen here and another hydrocarbon, means another group here. So means this CC double bond, it will form the cis-trans isomerism, because it could be different arrangement in space. Means this ethyl group, it can be another side. So when this ethyl group at another side, so it will form a cis isomer. This is the arrangement of atom in space. Means the structure is still the same and the molecular formula is still the same, but it can be different arrangement in the space. Means either it's the same side or different side. For the optical, of course, is a bit more complicated. Is about the mirror images. Right, means it must have a chiral center, and the opticals isomer, they are non-superimposable. So it's kind of that. So this is the definition. It's quite straightforward. Now, part 2. Deduce the numbers of stereoisomer in V. Explain your reason. The most of the answer, of course, will give 6 stereoisomers. But actually it's 8 stereoisomers. Okay, so let's focus on this structure and find the stereoisomers from this structure. So let's start with the CC double bond here. Okay, so we know that again, like what I told you just now, because these two carbon, they have 2 different groups, so it can form cis-trans. And after that, we need to find whether there is a chiral carbons or not. So this carbon is not chiral carbon, this one not a chiral carbon. Okay, all these carbon not chiral carbon, all this no. Only this carbon, this one, and this carbon is a chiral carbon. So means now we have 2 chiral carbon or 2 chiral center and 1 CC double bond. So many candidates will give 6 stereoisomer because it's like 2 plus 2 plus 2. But actually it's not 2 plus 2 plus 2. It should be something like this. Because now we know that there are 2 chiral centers and 1 CC double bond. Because each isomerism, it will form 2 isomers. And there are three possibilities or 3 centers now, right? So chiral center and the CC double bond means 2 not times 3 is actually 2 power 3. So therefore we can get 8 stereoisomer. This is how we get the total stereoisomer, because we have the 2 2 chiral center and 1 CC double bond, and each of that we know that it will form 2 isomers, but it's not 2 plus 2 plus 2, it's actually 2 power 3, so you get 8 stereoisomer. Okay, that's how we get it. Yeah, okay, hope you understand. Now part 3, deduce the molecular formula of V. This is very easy, you just count on it, count the carbons. Of course you need to know the elements inside there. Elements is carbon, hydrogen, oxygen, right? So if you count, so you get 13 carbon. Hydrogens, you need to count carefully. Okay, let's start with you for this hydrogen number. Here is 3, 2, 1, 2, 2, 1, 2, 1, 1, 2, 3. So if you sum up all these hydrogen, so you will get 20. Oxygen, of course, is very obvious, it's 3 only, right? Okay, part 4. Name all the functional groups in the V. This one you need to follow the latest syllabus. The latest syllabus, ester is still ester, right? So when you see this ester group, you just put ester as functional group. And this one is, of course, this is ketone, because this carbon with 2 alkyl group, so it's ketone. But if you want to give a better answer for functional group, whenever you see this ketone or aldehyde, the functional group is carbonyl. And when you see a CC double bond, of course, most of you will say alkene. It's actually nothing wrong. Alkene is a functional group. But if follow the latest syllabus, you need to put CC double bond. This is a functional group. If you check the syllabus, and you will know, and you'll see the functional group in the table. Okay, therefore the better answer is ester, carbonyl, and CC double bond. Part B. Figure 6.2 show 2 reactions involving V. So now V is the molecules just now, and is undergo the reaction 1 to form this product, and reaction 2 form these products, right? Means that W and X. Let's look at the answer. The question. See what they're asking. Part 1. Identify the role of reagent T for each functional group that reacts in the reaction 1. So what is the role of this reagent T? Then we need to compare and see the difference between V and the W. If you check, then you know this is the one that changed from this carbonyl or the ketone to form this alcohol. Second change, from this alkene now is saturated from alkane here. So these are the 2 changes, and these 2 changes actually has one similarities. Hydrogens added to these 2 groups. So this ketone, okay, now is 2 hydrogens added to that, to form this secondary alcohol. And this CC double bond, or this alkene, also add 2 hydrogen. So we know that when a compound added 2 hydrogen or hydrogens added to this compound, so it's undergo reduction. So it's quite clear that the V is undergo reduction because hydrogens added. And the reagent T, of course, is not really that important here. You just need to know what is the role for this reagent T. Again, we now undergo reduction. Reagent T must be reducing agent. In your syllabus, you need to know the reductions that for this carbonyl and the CC double bond, and it's actually use 2 different reagents. For the carbonyl, we normally will use sodium borohydride or lithium aluminum hydride, so it will reduce to this alcohol. For the CC double bond, we will just use the hydrogens with platinum catalyst. Of course, it needs a certain heat, about 140 degrees C. Then it will undergo this hydrogenation. So this is also a reduction. So there are 2 different reduction here. But you no need to identify what is reagents T. You just need to mention the role, right? So, and it's very obvious reagent T because it's helped the V reduce to W. So reagent T must be reducing agent. Okay, I put these 2 is just to let you know how the these reductions happen for these 2 functional group using different reagents in your syllabus. Okay, so part 1 is very easy. So the reagent T is a reducing agent for this carbonyl and the CC double bond. Part 2. Suggest the identity of reagent U in reaction 2. This one then you can identify what is a reagent U. Okay, now let's compare the compound V and the X. So the difference now is more obvious because only one change. So the ketone here now is formed the alcohol. So means this is a reduction again. And reduction for this carbonyl group, we can use sodium borohydride and lithium aluminum hydride. But in the mark scheme, it's only put sodium borohydride. There is a reason. Because when we use the lithium aluminum hydride, actually some of the functional group or one of the functional group, it will react. So it's actually the ester, but it's not in your syllabus, so the better answer is a sodium borohydride. So not the lithium aluminum hydride. So if we use sodium borohydride, confirm we can get X. If we use the lithium aluminum hydride, and this one might react, right? So therefore, we just follow the answer in marking scheme, which is a sodium borohydride, okay, to form this compound X. Okay, so answer is this, sodium borohydride, or you can name it. Part C. Both functional groups in one molecule of Y reacts with an inorganic reagent to form one molecule of Q. So this one is many of you might confuse. Many of you might thought that this is hydrolysis. In fact, this is not hydrolysis. If you try to do the later part, you know this is not hydrolysis. Later I'll tell you what it is. Yeah. Later we will get back to these reactions and let you know what is this molecule and how to form that. Okay, let's focus on the question. Again, just follow this the information. Y reacts with a reagent. Later, I will tell you the reagent in details. And to form Q and methanol. So now, the Q and this methanol, Q and methanol is from the Y. And we know that Y has 13 carbon. And the Q, therefore, it must be 12 carbon inside there. Must be 12 carbon. Because the other product, methanol, has 1 carbon. So Q, inside Q, it must be 12 carbon. Because total carbon must be 13. So you need to understand this for part 1 later. Right? Okay, so for this part 1, part of the mass spectrum for Q, okay, is shown in this figure 6.4. Only peaks with the M over E greater than 198 are shown. Okay, means this one. So from here is quite clear. M over E 200 and M over E 201. So this one, the 200 is the M positive molecular ion, yeah, M positive. And 201, this one, is just extra 1 mass unit to this 200. Means this is M plus 1. So is the Mn plus 1 means we need to use this equation. The relations between the Mn plus 1. This one you must remember. And just now, I already told you in the Q, because this is the mass spectrum of Q, it must be 12 carbon inside there. Okay, again, because Y has 13 carbon and it's from 2 products. One product is methanol, 1 carbon. The Q must be 12 carbon. So you must use 12 carbon for this calculation. Means we have this N equal to, N is a carbon number, equal to 100 over 1.1. This is a ratio between the carbon 12 and carbon 13. So carbon 12 and carbon 13, their ratio, times the abundance of the M plus 1, which is caused by carbon 13, and the relative abundance of the M positive, which is caused by carbon 12. So this is the comparison. Means you need to use this equation to get the X, because X here is the relative abundance of the M plus 1. 100 is the relative abundance of M plus. That's how you analyze and how you get the information for this from this mass spectrum. So now it's quite clear. The ratio between the carbon 12 and carbon 13 is always same, like this. 100 over 1.1 times abundance of M plus 1. So it's X over abundance of M plus, which is 100 here. Then you need to put 12 here, because the carbon number from the information just now, so is 12. So from here, rearrange, you get X. The relative abundance of this M plus 1 now is 13.2%. So this is how you get the X, the relative abundance of the M over E201. Okay, I hope you understand. This is a bit challenging for those who not really understand mass spectrum. Part 2. Q contains only hydroxyl functional group. Complete table 6.1 to show observations that occur when 2,4-DNPH is added separately to the Y and Q. Okay, now again, follow the question, the instruction. Q only has the hydroxyl, means OH functional group. And Y, molecule Y here, it has two functional group. It has the ester and this carbonyl. So because of this carbonyl, so it will react with the 2,4-DNPH and form the orange precipitate. Because in the question, it's already told you, the Q is only has hydroxyl group, no carbonyl group. So means Q will not give orange precipitate. So that's the observation. Okay, why here you must put orange precipitate form with the 2,4-DNPH. Q will not form this orange precipitate. So that's the observation. And okay, let's move on to this part 3. This part 3 is another the calculations for these numbers of hydroxyl group. Okay. So before we discuss this calculation, it's better to move back to this the initial part. Then you can understand better here. Okay, just now I mentioned from the Y to form the Q. So this is not hydrolysis. Because this one, this inorganic reagent is actually out of your syllabus. So means in your syllabus is never mentioned. You really need to understand and study this one. That's why it's never really asked you what is this reagent. Okay, so if let's say now the compound Y form Q and the methanol, and the Q only has hydroxyl group, as mentioned just now in the question. So means first is not hydrolysis, and it must be others. So the inorganic reagent is actually lithium aluminum hydride with the acid or water. Right. So the one that reacts is actually this part and this part. So because we know that when the carbonyl reacts with lithium aluminum hydride, it will form, of course, it will form this secondary alcohol, right? This one. And the ester also will react with lithium aluminum hydride. So how it reacts? First, this part, this carbonyl group, oxygens must be removed because it's a reduction. Oxygens must be removed, and after that, 2 hydrogens added. So it will form this CH2. So from this carbonyl, form this CH2. I hope you can see. And of course, this one need to break. Means the methyl group and the O here must break. And the methyl group will form this methanol, and the O here will form the OH, the hydroxyl group. This is how the reaction should be, but you no need to really understand this reaction because it's not really in your syllabus. That's why it's not really asked what is the reagent. So means I just try to tell you how this compound Q form. So means in this compound Q, after the reaction, it will form 2 OH group. And if you understand this reaction now, when we discuss the calculations later, then you can understand better. Okay, now let's move on to this part 3. Under certain condition, 0.002 moles of Q react with excess sodium to produce total 44.8 cm cube of gas at STP. STP molar volume is 22.4 dm cube. Calculates the numbers of hydroxyl groups in the molecule of Q. First, of course, you need to know if there is one hydroxyl group, means OH group, when it reacts with sodium, it will form half mole of hydrogen. That's a comparison. So means 1 mole of OH will produce half moles of H2. Now, let's calculate the moles of the gas that produced. Because it's 44.8 cm cube, so you need to use 44.8 over 22400 cm cube. Okay, so convert the dm cube to cm cube, you get this, and you get 0.002 mole. So now, after calculations, we know that the moles of gas that produce is 0.002 mole, which is same as the moles of the Q. So 0.002 moles of Q produce 0.002 moles of gas. Therefore, we are quite sure in the Q it has 2 hydroxyl group. Because 1 mole of OH form half mole of H2. Right? So, but now is 0.002 from 0.002, 1 to 1. It shows that it must be 2 hydroxyl in this molecule Q. I hope you understand. Okay, last part. Use table 6.2, describe and explain 2 differences between the infrared spectrum of the Y and the Q. Of course, you must focus the one that above 1500 per cm, or this we call wave numbers. Now, let's focus on the Y and Q and get their difference. Okay, so let's compare Y and Q. So in the molecule Y, so it has a carbonyl, and the Q doesn't have this carbonyl. That's a different, no? And for the Q, it has hydroxyl group, and the Y don't have hydroxyl group. That's a different, 2 differences. Again, Y has a carbonyl group, and the Q has hydroxyl group. So you need to focus on these 2. So because now we know that Y have the strong absorption, means a carbonyl group, so you need to find from this table the carbonyl group here. So you just get the absorption range here. So for the Y, it has the CO double bond, and it will show the absorption between this range. Okay, so you just explain this one. So Y will have a strong absorption between 1670 to 1740. Okay, it's due to what? The CO double bond, the carbonyl. Okay, the Q, because just now I told you Q has hydroxyl, so you just focus on this hydroxyl and the range. So because it's OH, and it must be the alcohol, means the hydroxy, and so you just explain Q will have a strong, you can say strong or broad absorption between these wave numbers, right? 3200 to 3650 is due to this OH bond. Okay, that's all. Thank you.